I'm going to show you a multiplication set of problems so that you see the pattern in this last one. Because sometimes rather than me just telling you the pattern, if you kind of recognize it, it'll lock in your brain a little bit better. Right, Malachi? So, if I give you a multiplication problem of x plus 4 times x minus 4. How do you multiply polynomials? What method do we use? Yeah. The distributive property, for those of you guys who are too advanced for the box. Such childish things, drawing a box. But for the rest of us mortals, we're going to go ahead and set up a box to help us distribute.
I like the box better.
So, what's x times x?
I forgot what this
X squared. What's negative 4 times x?
Negative 4x.
Negative 4x. What's positive 4 times x?
4x.
4x. And what's positive 4 times negative 4? And so, when we combine like terms, what happens when I combine these like terms?
Cancels out. Oh no, it cancels.
They cancel out. So what is the product? What's the answer?
X squared minus 16.
X squared minus 16. So we've kind of been relying on this pattern lately where two binomials multiplied together typically match with a trinomial, right? So we end up with a 2 by 2, usually makes a 3, but in this case, you can put the doorstop in so he can hear. So we just combined like terms. 4x and negative 4x cancel each other out, and all you're left with is x squared and a negative 16. Okay? So, in this situation, what we're having is it's canceling out and it's not making the normal trinomial that we usually see when we do a box. And so, this is kind of an interesting concept. What about 3x plus 7 times 3x minus 7? Yeah, 3x plus 7 times 3x minus 7. Again, it's a multiplication. So I'm going to set up the box.
Why isn't it all
Not
Or
everything.
no, not the.
So fill in the box. Let's see if that same phenomenon happens again. Yeah. Who's got the final answer for me? Reese, what'd you get?
9x squared minus 49.
9x squared minus 49. So we end up with this negative 21x and positive 21x cancel each other out. And really all I ended up with was 9x squared and negative 49. That's really all that counts. So see if you can do this one without setting up a box. Just following the pattern, right? Ignoring the box concept. How about 2x plus 5 times 2x minus 5? Squeeze it in there. So try, see, give everybody else a chance.
4x minus 25.
So it ends up being 4x squared minus 25. Now, what do you think?
Why can't we use the box method?
You can. You can absolutely use the box method, but what I want you to notice is when I have the exact same factor times itself with one change, what one change happened? What's different? These two are the same factor except for what?
Negative.
Yeah, the positive and negative, right? I tend to call this the plus minus factors. Like when I have the same thing, but I've got the plus and the subtraction, then what ends up happening is they end up canceling out that middle term. Mia, what are you thinking? Well, because what does difference mean in math?
It's different.
Do you notice how all of my products have subtraction in them? And then when it says 2 squares, what do you notice about 16, 9, 49, 4, and 25?
I can do like 9 and 9, so like something
4 times 4 is 16.
So, okay, let's write this. Difference means subtraction, okay? Difference means, hang on, let's write this down first. Difference means it's got to be subtraction. And then squares We're talking about the perfect squares 1, 4, 9, 16, 25, 36, 49. If you're sitting there thinking, where is she coming up with these? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, all the way up.
47.
You could do 47 times 47. Really, it's mostly the common ones that you know. It usually goes up to about 144, which is 12 times 12. You'll see 225 sometimes, which is 15 times 15. These are multiplication facts that should kind of pop in your head quickly if you know your multiplication facts. Perfect squares are ones that should be familiar to you. Yes, ma'am.
So if you wouldn't have gotten any of those answers, you would know you were wrong.
Yeah. So here's where this is useful, is if we suddenly try and reverse it. If I give you the problem, because again, remember, we're factoring right now. We're not trying to multiply. I did some multiplication to show you this pattern. But if I give you an answer like x squared minus 64.
But you already have your answer. Oh, wait. Yeah.
So I want to know what are the factors that would create that.
8 times 8.
Jake Williams knows his multiplication facts better than any kid I've ever seen. So how do I get the 64?
8 times 8.
8 times 8. And I'm going to need a positive 8 and a negative 8. And then how do I get x squared? X and x. Okay? So, by the way, I should probably add this up here where we were listing kind of some of those perfect squares, dot, dot, dot. Let's also consider that x squared is a perfect square. It's x times x. So we've got 1 times 1, 2 times 2, 3 times 3, x times x. Okay? So if you see a problem, when I look at this, you know, we've talked about the different categories of factoring we have. There's not a GCF, so that's category 1. It's not a trinomial, so that takes out simple trinomials and complicated trinomials. But now there's this fourth category it might be. It might be the difference of 2 perfect squares. And if that's the situation where you go, okay, I've got perfect squares and they're being subtracted, then it's x plus 8, x minus 8. It's the 2 square roots with a plus and a minus. Chandler.
Is this the new method?
Yes, this is the new method. So it's really pretty easy if you recognize how it goes. So if I give you a problem like 36x squared minus 81. First off, who can explain why does this fit the new category? What criteria is it meeting? They're both perfect squares. 36 and 81 are perfect squares. Is it a difference?
Yeah.
It's subtraction. So if it's the difference of 2 squares, then I know I'm going to have the plus minus situation.
Wait, let me get
Okay, hang on. Think first, and then we'll share.
Ooh.
So,
I know this one.
think
I know
without
it.
your mouth. Austin Sheffield, what's going to make this?
6x squared plus 9 and then 6x squared minus.
That's wrong.
Okay, hang on. Y'all are so quick to judge. Somebody raise your hand and tell me what's the issue with Austin's answer here, Chance.
You have 2x squared, that's
That'd make x to the 4th, right? So I don't want that. I just want x and x. Okay? So you gotta think, you gotta think, what times itself makes 36x squared? So check it real quick. You get 36x squared, you get 81, and then the middle terms that's missing, the middle piece, is actually canceling each other out if I do the box.
Is there going to be a complicated version of it?
No, this is all it is. This is all it is. So if I give you a question like
easy peasy lemon squeezy.
I'm not expecting.
x squared plus 100,
This one,
Just call it 100.
no, not
Wait,
yet.
is that it?
Oh, I'm zooming the wrong thing.
we're gonna have positive.
So x squared plus 100,
I got it.
what do you think, DePorter?
X plus 10 times x minus 10.
Nope,
No.
Oh,
X
Jake?
Hey, x plus 10 or times x plus 10.
nope,
Wait,
Reese?
X plus 20, X plus 5.
nope.
it's x plus 10 and x plus
Would it be an X plus 10 squared?
Nope. Is this okay? So let's go back to our. Does this meet the criteria for the difference of two squares? This is not a difference of two squares. So right, not, and I'm gonna abbreviate so I don't have to write it. Not a difference of two squares. There you go. Literally two squares. It's not a difference of two squares. Is there a GCF?
Yes.
What?
1.
Is a 1 relevant in this situation? No. So it's not a GCF. Is it a trinomial? No. So you know what? If it doesn't match any 3 of those, it's not a difference of two squares, it's not a GCF, it's not a trinomial, it's a prime. Okay? They're rare, but this is why through the warm-ups I've been kind of trying to get you to think about what category are we falling into. This is just a 4th category that we're checking for, okay? But the key is it has to be difference, it has to be a subtraction, and they have to be perfect squares. So if I give you 25, what is what? That says trinomial with an X not next to it. Because it's not a trinomial, it doesn't have 3 pieces. How about 25x squared minus 400? Let's go up to a high number.
Oh, this is big numbers.
And right now, I would go ahead and check, because I mean, we are in the notes over difference of two squares. Is it a difference?
Yes.
Is it two squares?
Yes.
Yes, it is. So,
Figured it out.
if it's the difference of two squares, I know we're talking plus minus factors. GT, what are they?
X plus 20 and X minus 1.
Go.
No, 5x
5x.
plus
That's
20.
what I meant. That's what I
5x.
wrote.
She wrote it. She just didn't say it. So 5x and 5x will give me the 25x squared. 20 and 20 will give me 400. Okay? This is actually on your formula chart. So write down formula chart. And here's how it's written on the formula chart. I personally think that this is a little bit confusing. Is it says a squared minus b squared. If you have, oh, careful about saying this is easy, because that's right about the time you get confused.
Oh, no,
So, but just so y'all see, on the formula chart, it has difference of squares. And it says a squared minus b squared equals,
A minus B plus, no, times A plus B.
yes,
What?
a minus b times a plus b. A minus b times a plus b. I've been writing them as plus and then minus, but it doesn't matter what order you write the factors. So notice, the subtraction is the difference. It has to be a difference.
I wrote my
And that has to be a perfect square. Okay. And that has to be a perfect square. I'll fix it in just a second. So that's what the formula chart says about it, okay? All right. I'll do examples.